In many real-world scenarios, like waiting in a line or service queue, it is important to process tasks or customers in the order they arrive. This is where the queue data structure comes in handy. A queue works on first in, first out principles, meaning that the first element added is the first one to be processed, just like the first person in the line is the first to be served. In this tutorial, we will create this app, as seen on the screen, that allows the user to add and remove and search for people in the queue. For example, if I want to search the queue for names that contains LI, I just type in LI, and then all the names that contain the letter LI are filtered and displayed here. And then if I want to delete from the queue, I can just click on DQ button, the red button. At the moment, the queue has 4 names: Alice, Bob, Charlie, and David. So now I will delete from the queue. As you see, Alice was deleted. If I wanted to, I can now add a new person to the queue. I'll just add James, 30. To add a new person to the queue, I need to click on NQ, which is the green button. And as you can see, James was added to the end of the queue. And then if I want to peek to see who is the next person in the queue, for example, for an appointment to be seen, just click on the peek at front person button, the blue button, and then it should say or show Bob. Yeah, Bob is the next person to be seen in the queue. So now I would delete Bob from the queue. Just click on DQ to remove Bob from the queue. As you can see, Bob has been removed from the queue. And then if I click on the peek button again, it will be Charlie that is the next one to be seen within the queue. And this is the functionality we are creating in this tutorial. The first thing we need to do is to create a struct called person. Struct person identifiable let ID equals UID, let name string, let age int. The next thing we need to do is to create a class called data, and this will populate our list and our queue. Class data static function create array of people in background. As you can see, we're using a completion handler. Which will return an array, a person, and then the next thing we do is to simulate an asynchronous task using global dispatch queue. Because really, this should be coming from an API. And then we include a little delay in seconds, which will be about 2 seconds, 2.0. Dispatch queue, global, async after. So this queue will be executed after 2 seconds. Now execute, or we can just do now plus delay in seconds. Let array of people and then we populate our person objects with name and ages. So we add the first object to the array, and then the second, the third, and then the last element we add to the array. And then we pass our array to our completion. Just compiling at the moment. In next week's tutorial, we will add our queue data structure to the application. Within your project, add a new Swift file. Name the file queue. This will be the queue data structure. Type in the following: public struct queue element and the purpose of that definition is to define a generic struct named queue that can hold elements of type element. So it can hold an array of different types of elements. Private var storage element so that holds an array of elements within the queue. Public init, we just create our default public initializer, which is needed sometimes for creating an empty queue. So the next thing we need to do is to create another initializer to populate our queue. Element storage equals elements. So what that does is a public initializer that takes an array of elements and initializes the queue. Then we have to create a public mutating function enqueue element. So this mutating method's purpose is just to add items onto the queue. So we have to use storage dot append and pass the element. For example, the person's name and their age, that will be the element. The next method we need to create is our mutating function dequeue method. Elements. No, that should be element, not elements. So the purpose of the dequeue method is to remove items from the queue. So the first thing we have to check if the queue is empty. If storage dot is empty, return nil. Else return storage dot remove first. So it removes the first item at the top of the queue. The next method we need to create is our public function peak method that returns an element which can be optional. Return storage dot first. So the purpose of the peak method is just to retrieve the next customer to be processed that's within the queue. And then we're to create a computed property to check if the queue is empty or not. So this computed property will return a boolean if it's empty or not. And to enable the user to search the queue, we need to implement a find by name method, internal function find by name, which accepts a name, which is a string, and returns an array of people. Return storage dot compact map $.0 as person filter $, dot name contains name. So what we're doing there, we use compact map to filter and cast the elements to a person type, and then filter based on the name that the user typed in. In the next tutorial, we will implement our content view to use our queue data structure. We will now implement the content view to use the queue data structure. At state private var matching people So the purpose of that variable is to hold an array of matching people in our filter. That should be called person and not people. At state private var people we create another array called people, and that is to populate our list. At state private var queue equals queue person we create and initialize an empty queue array. At state private var dequeued person, which is optional. @state private bar new person name. So this will hold a new name for the person that we can enter to be stored within the queue. @state private bar new person age string @state private bar search name string @state private bar show alert equals false, and @state private bar alert message. The next thing we need to do is delete lines 23 and then add a navigation view. VStack and then a form. Within our form we have some sections. It's called all people. If people dot is empty, if the array is empty, display this message: no people in queue. We just add some style to the text element, footnote, foreground color grey, else that means it's not empty, so we can populate our list. Make sure each element within the list is unique by using .id, person in, VStack, alignment, .leading, text, person, .name, .font, .headline, text, age, person, .age, .font, .subheadline. Missed out a bracket on lines 39. And another closing bracket. Just compile it. The next thing we need to do is to add a section to enable searching. So we add that section after lines 49. Section header text, search people, VStack, add a text element, search name, add a spacer, text field, enter name to search, and the name to search on will be the search name, dot text field, text field style, rounded order text field style, auto capitalization, is none, dot frame, max width 200, dot on change, of search name, new value in, so on line 63 we need to create or call a method called search people by name. So I just add a comment here, search people by name, just add a to do, next thing we need to do is after line 67 we need to display all the matching people based on the search criteria, based on this variable, and then populate our list with all the matching people or all the matching names based on the search criteria. Matching people dot is empty, text, no matching people found, font dot footnote, foreground color gray, else populate our list with the matching search criteria. VStack, alignment, leading, text person dot name dot font dot headline text age person dot age dot font dot subheadline. The next thing we need to do is add the input field to allow the person to add a new person, to allow the user to add a new person to the list or to the queue, so that the information can be repopulated on the list. So we do that after lines 93. Section header text, add a new person. So to add a new person, we need to create a B stack for our UI elements, H stack, text element that has the word name, and a spacer, and a text field to enable the user to enter the new name of the person that they want to add. New person name. And we do a similar thing for the age afterwards. Text field, style, rounded, border, text style, dot frame, max width 200, and we do the same thing for the age. So we just copy lines 97 to 104, and then we just paste it after lines 104 anywhere here. Update name to be age, enter age, new person's age, and for the max width, just make it 100. And then we just add a spacer to push the buttons to the bottom. So we'll be focusing on the buttons next week, next tutorial. And also adding the other methods that's needed for the content view. In this tutorial, we will continue with the content view to implement the buttons for NQ, DQ, PCAP front person, and other group operations that we need to do. So the first thing we need to do is to continue from line 119. We need to add our V-stack, spacing, as each button will include 20 pixels of space. Button NQ, so we need to create our NQ person method. So let's just create that now. Create it anywhere after lines 129. Private function NQ person, and the purpose of the NQ function is to enable the user to add a new person to the queue, and this will include the person's name and the person's age. Equals int, so we convert the person's age to an int. Person name is empty, so if it's not empty, then we get the value, else we just exit. Now we have the value of the person's name. And their age. We then pass those values to the person constructor or initializer init method. New person name, age, and age. Q.NQ, new person. So we add the new person onto the queue. People.append new person. Add the new person onto the people's array. New person name equals comma comma. New person age equals comma comma. So now we can return to lines 125 and then call the end queue person method. we need to add a frame to the button to enable each of the buttons to be the same size using infinity, dot padding, dot background, color is green, dot foreground, color is white, corner radius for curvy corners, which is 8. The next button we need to create is called DQ. And the purpose of the DQ button is to remove a person from the queue. So we need to create a new function which is called DQ, or DQ person. And let's create that function now. Private function or func DQ person. DQ person equals Q DQ. If let DQ person is equal to DQ person, so if it's not nil, if it includes the value people dot remove all $ dot ID is equal to DQ person ID. So if the IDs are the same, then remove it from the array. It should be people, spelled incorrectly. Remove all, that should be. So what we need to do now is return to lines 133 and call our new method, which is DQ person. And we do what we've done previously to the button, so that each button they're the same size. Change the background color to red. The next button we need to create is PCAP front person. button, peak at front, person, so we need to create a new method called peak person. Private func, peak person. If let peak person is equal to q.peak, so what that means, if there's something in the queue that exists, so it's not nil, then we get that person. Alert message is equal peak at peak person dot name, age, peak person dot age. Else, if it was nil or empty, alert message equals the queue is empty. Show alerts equals true. So what we need to do is what we've done previously with the rest of the buttons, with the other buttons that we created earlier. We have to assign the frame and infinity for the max width and the colors. So the background color will be blue and foreground color is white. Padding horizontal, (16), padding dot bottom 20. The next thing we need to do is to add a navigation title, queue operations, dot navigation bar title, display mode, inline, dot alert is presented, show alert, alert. So the overload that we need is the first overload. So that will be text, queue, operation, message, alert, message, and for the dismiss button, we will just use the default with an OK. With OK for the caption. The final thing we need to do now is to populate our queue and our array using dots on a pair. Data dot create array for people. In background, people in, so within this closure we'll be using dispatch queue.main dispatch queue.main async. On line 156, that should be in line and not line. Self.people equals people. So we initialize our people array, and now we will initialize our queue. Using a people array. Self.matching people equals self.queue.find by name, search name. And the purpose of that line is just a default search when loading the screen for the first time. Now I'll just compile it and run it to see if it works or not. As you can see, the application has now loaded. So if we want to add a new person to the queue, I'll just type in thread 22 for the age. Click on end queue. You can see thread has been added to the end of the queue. If we want to remove someone from the queue, just click on end queue, and then Alice will be removed from the queue because Alice is the first one in the queue. As you can see, Alice was removed. And we can also filter, so we can filter by name or few characters in the name. Type in LI. My Xcode is a bit slow. Type in L. Locates Charlie. Type in I. Locates Charlie and David. Or E. Charlie and Fred. Or a name that doesn't exist. It won't locate anything. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.